To start the demonstration, open Apex. We will first create a 1x1 square surface. We do this by clicking on the Geometry Create icon from the Tool palette. Click the 2-point rectangle sketching tool to draw our surface. On the screen, pick the XY plane, which, if you look at the interactive triad in the lower left corner of the screen, is the bottom plane. This is where we will create the surface. Once the plane is picked, zoom out and then click anywhere on the grid to begin drawing the square. Then click again to complete the square. If your dimensions aren't quite exact, you can change them by clicking on the one that is incorrect, typing in the correct value, and pressing Enter. In this case, we do this for both dimensions. Exit the sketching tool by clicking on the Close icon. To create the solid, we use Geometry Edit. Under the editing tools, click on Push Pull. We select the surface we just created and then type in 1 meter on the arrow to define the distance we want to extrude this surface. This will complete the 1x1x1 cube. Now let's define the material for the part. We click on the material icon, click on Create Material, change the name to aluminum, then enter the elastic modulus and Poisson's ratio. Once we've finished entering the material data, click on Assign Material and then click on the solid part to assign the material to the solid. Click on the Close icon. Next, let us apply the pressure load by clicking on the Loads and Constraints icon. Enter -50 pascals. We select a face normal to the x-axis. Once the pressure is applied, we can click on the Close icon. Now we will create the constraints that will allow this part to expand freely to demonstrate the effects of Poisson's ratio. Click on the Fixed Constraint icon, enter constraint_x for the name, then uncheck all other constraints except constraint translate x. We will apply this constraint to the face opposite the one to which the pressure is applied. Now we enter constraint_y as the name, then uncheck all other constraints except constraint translate y. We will apply this constraint on the face that's normal to the y-axis. Next, we enter constraint_z as the name, then uncheck all other constraints except constraint translate z. We will apply this constraint on the face that's normal to the z-axis. Finally, we apply the mesh by clicking on the meshing icon, selecting 2.5D meshing under Meshing Tools. For a mesh size, we enter 0.25 meters, then we click on the solid to mesh it. Now go back to the Model tab, right-click on Part 1, and select Set Analysis Context. Apex reports that there are no offenses identified and that the current analysis context is ready for submission to the solver. Before we run the analysis, we want to add an additional output request so we will be able to post-process strain. We click on the book icon to generate a simulation scenario. Under the Studies tab, right-click on Output Requests and select Properties. On the Output Requests menu, click on Strain. This will add strain to the output requests list. Finally, we proceed to run the analysis by clicking the yellow running man. Now that the analysis has completed, click on the post-process icon. Now let's show the fringe plot by clicking the fringe icon. If we hover the cursor over the spectrum, we see that we are viewing the von Mises stress. Let's change it to the x component. We see that the value is 50 pascals throughout the part. Now let's go back and look at the y and z components of stress. We see here that in comparison to the -50 pascals in the x direction, the stresses in the y and z directions are essentially zero. Because of this, if we go back to von Mises, we can see that it too is 50 pascals. Now let's show the strain in the x direction. Here we see that it is 7.25 E -10, which matches our hand calculations. And if we show the strain in the y and z direction, we see that it reports -2.17 E -10, which matches our hand calculations. Since the value is negative, this indicates compression. Finally, let's do an animation of the deformation to show the effect of Poisson's ratio due to the loading. Simply click on the play button to start the animation. This concludes this demonstration.